Good morning everyone. So for today class science, so we're just gonna continue with the new chapter, elements, compounds and mixture. Okay, as you can see this is the diagram. Okay, the first one here shows that it's an element. Okay, so hydrogen gas in an element. Okay, as you can see above, okay, this purple color circle. Okay, it is made up of molecules containing the same atom. Okay, same type. Okay, so only one type of atom appears in hydrogen gas. Okay, for the second diagram here, as you can see, you have two pink color and one, let's say light blue. Okay, almost white. So this one, okay, they are different. Okay, so let's say this is a water. Okay, water is a compound. Why it is called as a compound? Okay, because it is made up of molecules with two different types. Here, this is the keyword. Okay, different types of atoms. That's why we call that as a compound. Okay, for this one, the third diagram here. Okay, so air is a mixture, so which means that it is made up of different elements and compounds. Okay, so you have the hydrogen here. Okay, you have the water. Okay, and you have here is another, let's say another thing. Okay, another compound or another element here. Okay, since these two are different, so you call this as a compound. Okay, so now we move on to the next slide. Okay, so let's say we will go one by one. Okay, elements. So what is an element? Okay, so all matter is made up of elements. Okay, an element is the simplest form of a matter. Okay, an element is only made up entirely of one type of atoms. For example, like in this diagram, okay, as you can see, oxygen is only made up of O. Okay, O atom. Hydrogen is H. Iron is Fe. Okay, gold is Au. Okay, carbon is C. Okay, we call that as a element. Okay, for example, like gold is an element. Okay, because no matter is in solid, molten or liquid state. Okay, only atoms can be found. Okay, it cannot be further broken down into a simpler form of matter by chemical or physical means. Okay, so as element cannot be decomposed, a common way to identify whether an unknown substance is an element is to heat up or pass an electric current through it. Okay, so this is to check that whether the unknown substances, the process or the method, you check if the element is an element or not. So you do the first method is you heat it up, or you put the electric. Okay, let's say if decomposition is occur, which means the separation. Okay, decomposition which means separation. Okay, the substance is not an element. Okay, so each element differs from one another. Okay, oxygen is O, H, K, they are different, right? So each element has a name as well as chemical symbol. Okay, we call it as a chemical symbol. Okay, here's the name. Oxygen stand for, O stand for oxygen, H stand for hydrogen. Okay, so chemical symbol can consist of one or two letters, where the first letter is always a capital letter and the second one is and the second one in lowercase. This one first must be capital letter. Okay, that's why here F bigger letter, A is smaller letter. Okay, so the last one here, some of the common elements are oxygen, hydrogen, iron, gold, carbon, and so on. Okay, so how do we classify the elements? Okay, so this is a subtopic. Okay, classifying elements. So different elements have different properties due to the difference in the number of protons. Okay, you already learned that. The number of protons, number of neutrons, electrons found in the individual atoms. Okay, as you know that atom is made up of, you have the electron, proton, and neutron. Okay, so each element, which is for example, like oxygen, this one, each of them will have a different number of proton, number of electron, and number of neutron. Okay, so that's why they have different properties. Okay, so they also can differ in chemical and physical properties. Okay, some of the physical properties used in comparison between elements are the color and appearance, melting and boiling point, malleability and density. Okay, so these are the difference that we can make. Okay, on the other hand, chemical properties usually refer to how the elements react chemically. Okay, the elements are arranged in a systematic manner, according to the certain properties into the periodic table. Okay, what is periodic table? So this is the next slide, show you the periodic table. Okay, so last time I already show you guys, okay, and also give you guys the periodic table. So these are the periodic table. So from here you can see that, okay, each element is, okay, is written here. Okay, so you have the H stand for hydrogen, Li stand for lithium, Na stand for sodium. Okay, let's see here. F stands for fluorine. Okay, Cl chlorine, S sulfur. Okay, so this one is the chemical symbol, this one is the name. Okay, this is recorded as a periodic table. Okay, so from the periodic table, okay, so this is the explanation about the periodic table. Okay, one of the features of the periodic table is a zigzag line. Okay, this zigzag line separates the elements that are metal on the left from the non-metal elements on the right. Okay, we go back to the periodic table. Okay, on the left side, normally here, okay, here, the black here, until here, okay, all on the left side here will be known as a metal group. Remember that? Okay. On the right side here, where it is the black color here, okay, separate them. We call it as a non-metal group. Okay, please take notes on that. Okay, so the elements can be categorized according to the states at room temperature. Okay, the metal elements always exist in the solid state and room temperature with the exception of mercury. Okay, only the mercury which exists in the liquid state. Okay, which means that mercury, okay, let's say you put in a room temperature, okay, we say that normally all the elements will exist in solid state except for mercury. Okay, if we put in a room temperature, it will exist in the liquid state. Okay, so the elements in the table are arranged in periods, okay, which are horizontal row, as well as groups, which are the vertical columns. Okay, horizontal row. Okay, horizontal, which means you go from the left, move to the right. Okay, we put as a period. Okay, I repeat again. Okay, which means you move from the left, go to the right like this, follow the mouse. Okay, so this is the period. Okay, for groups, we from the vertical column. Vertical is, let's say, from the top go to the bottom. Okay, we say this is the group, and this is the period. Okay, moving from the left to the right of the period, elements shows a gradual change of properties from metallic properties to non-metallic properties. Okay, as I mentioned earlier, okay, if you move from left to go to the right, okay, let's say that just the number 3 here means, okay, period 3. Okay, if you move from Na here, go to the Ar here, okay, same row. Okay, so this will be starting here will become metal, okay, and then go, okay, and then continue, again slowly become non-metal. Okay, so if metal, then slowly go to become non-metal. Okay, in period 3. Same goes to other period. Okay, period 1, period 2, 3, 4, 5, 6, 7. Right? So there are altogether 8 groups in the periodic table, and elements of the same group have similar chemical properties. Okay, elements that belong to the same group, okay, will have a similar chemical properties. For example, like group 1 elements tend to be reactive, while elements of group, okay, the 0 here, elements are inert and unreactive. They are usually referred to as noble gases. Group 1. So group 1 we start with here. This is known as a group 1. Okay, hydrogen, lithium, sodium, potassium. Okay, this is a group 1. This is metal here. Okay, all are metal. Starting from the top, go to the bottom here, all are metal. So if you go to the last one, okay, group 0, this is the non-metal, okay, known as the noble gases, right? Okay, so let's see here, okay, the properties of metals and non-metals. Okay, so let's see here, okay, metals and non-metals have different physical properties. Okay, let's see the first one, okay, difference. Okay, physical state at room temperature. Okay, let's see the metal, solid with the exception of mercury. Okay, that is for the metal. Okay, all metal is solid, okay, except the mercury. Okay, mercury is in liquid. Okay, no metal exists in all 3 states. Okay, how about density? Metal, of course, is high density because of the mass. Okay, non-metal, okay, low density. Appearance, so normally shiny surface reflects light. Okay, dull surface, okay, does not reflect light. Okay, that is the properties for non-metal. Malleability, okay, so can be beaten into thin sheets, okay. For non-metal, cannot be beaten into thin sheets, okay. They normally easily to break up, okay, broken down. Ductibility, okay, can be drawn into thin wires, okay, for metal. Okay, for non-metal, of course, cannot be drawn into thin wires. Melting point for metal, of course, is high. Okay, high melting point compared to the non-metal is low melting point. Okay, boiling point, same goes, metal, high boiling point, non-metal, low boiling point. Electrical conductivity, metal is good electrical conductor, okay, except for non-metal, okay, non-metal is poor electrical conductor. Thermal means heat, okay, heat. Okay, thermal conductivity, metal is a good thermal conductor, okay, but non-metal is a poor thermal conductor. Hardness, for metal is hard, non-metal is non-hard. Okay, soreness, okay, for metal make a characteristic sound when hit, okay, shape like sound like a ring, okay, the ringing bell. Okay, for non-metal does not make characteristic sound when hit, okay, does not produce sound. Okay, that is the physical properties for metals and non-metal. Can non-metal have three states at room temperature: solid, liquid, and gas? Okay, all of them, this is known as a non-metal. Okay, so the table shows how some of the non-metal elements are classified according to their physical state at room temperature. Okay, solid, you have carbon, iodine, boron, okay, silicon, arsenic, phosphorus, and sulfur. This is a non-metal. Bromine, only liquid is only bromine. Okay, gas, you will have helium, hydrogen, okay, oxygen, nitrogen, neon, chlorine, fluorine, okay, argon. Okay, these are known. All of them are known as a non-metal. Okay, the uses of metals, okay, due to their ductility and malleability, metals are soft and weak. Okay, however, metals can be strengthened by mixing them with other metals or non-metals. The end product is called alloy. Okay, which will be harder and stronger. Okay, an alloy is a mix. What is alloy? So an alloy is a mixture, okay, which consists of metallic element with one or more other metallic or non-metallic element. Okay, let's see some example here. Okay, the table here below shows that. Let's see the first one, steel. Okay, steel is an alloy. Okay, why we call steel as an alloy? Because it's a mixture between, okay, elements of iron plus carbon. Okay, this one is metal, this one is non-metal. Their properties now become more harder than iron. So the uses for steel, okay, usually for nails, screw, railway lines, okay, which is the railway lines, okay, bridges, buildings. Okay, for brass, also known as the alloy, okay, because it's a mixture between copper and zinc, metal and metal. Okay, now the properties of brass is more stronger and more valuable than copper. So uses for brass is nuts, okay, bolts, okay, tubes, decorative items. For bronze, copper plus tin, okay, both are metal. So now the bronze has a high strength where, okay, can prevent resistance, okay, and good water resistance. Okay, so uses for bronze, coins, medals, statue, okay, and decorative items. Okay, duraluminum, okay, which is the mixture between aluminium plus plus copper. Okay, so now the property is now strong and corrosion resistant. Okay, the uses is for aircraft engines, car engines, pressure cooker, industrial cauldrons, okay, undersea vessels and ships. Okay, these are alloys. Okay, alloy. What is an alloy? An alloy is a mixture which consists of metallic element with one or more other metallic or non-metallic element. Okay, and again, here is the shows some of the common application of metallic element. Okay, the iron, gold, copper, aluminum, and also show you the common application. Let's say the example for gold. So this is for jewelry. Okay, copper is for coins, ornamental objects. Okay, aluminum. Okay, you have the bolt holes, window grills, airplane parts. Okay, let's see the mercury is only usually for thermometer, dental fillings. Okay, let's see the calcium. The calcium is for storage batteries, okay, used to make cement and mortar. Okay, you can try to look at this, okay, the common application for the element here. Okay, Okay, the last slide here for today's class. Okay, uses of non-metal. Okay, non-metal can also be useful depending on their chemical and physical properties. Okay, so these are the table here, show you the example here. Okay, the element for non-metal, let's say the first one, oxygen. So what is the common application? So you have the respiration process where you need oxygen to happen. The combustion also is a process, okay, that you need oxygen to happen. Yes, steel manufacture, okay, chlorine. Here we have the production of safe drinking water. Okay, neon, advertising signs, TV tubes, laser. Fluorine, we have the toothpaste, nitrogen, fertilizer, refrigerant, okay, explosive and nylon. Silicon, okay, you have the computer chips, medical implants, phosphorus for the fertilizer, pesticide, carbon for fuel and lubricant, okay. So hydrogen, rocket fuel, hot air balloons, okay, helium, balloons, okay, hot air balloons. Okay, okay guys, so thank you for today's class. Okay, thank you for watching this video.